Why is leakage as a percentage of system input volume a misleading key performance indicator? Using percentages of system input volume as a water loss KPI is often referred to as a zero-sum indicator. But what does that mean? A zero-sum game is one where whatever is gained by one side is lost by the other side, so the net change is always zero. Let's take a look at 4 scenarios to help your understanding. In scenario 1, system input volume in period 1 is 40 units, the consumption volume is 32 units, the leakage volume is 8 units, and the leakage as a percentage of system input volume is 20%. Imagine that the utility commits substantial expenditure to try to reduce both leakage and consumption by pressure management, leak detection, and customer assistance to reduce consumption. The strategy works. In period 2, system input volume, consumption and leakage have all been reduced by 12.5%. But what has happened to the leakage as a percentage of system input volume? Nothing, still 20%. And what has happened to the consumption as a percentage of system input volume? Nothing, still 80%. Now imagine that no leakage control, no pressure management, and no consumption management has occurred between period 1 and period 2, and system input volume, consumption and leakage volumes have all increased by 12.5%. What has happened to leakage expressed as a percentage of system input volume? No change, it remains at 20%. What happens to consumption expressed as a percentage of system input volume? No change, it remains at 80%. If the utility management or their regulators insist on using percentage of system input volume as a KPI, they will think that there is no need to spend money on leakage control or demand management, as leakage as a percentage of system input volume has not changed. And all because this traditional zero-sum indicator is useless for setting targets and tracking performance and is not fit for purpose. In scenario 3, now imagine that in period 2, consumption volume has reduced by 4 units, but leakage volume is unchanged. What happens to leakage expressed as a percentage of system input volume? It has increased from 20% to 22.2%, but the leakage volume is unchanged because this is a zero-sum indicator, not fit for purpose. Consumption expressed as a volume decreased by 12.5%, but as a percentage of system input volume only by 2.2%. In scenario 4, let's imagine that in period 2, consumption increases by 4 units, but leakage volume stays the same. What happens to leakage expressed as a percentage of system input volume? It has reduced by 1.8%, even though the leakage volume is unchanged, not fit for purpose. Consumption expressed as a volume increased by 12.5%, but as a percentage of system input volume only by 1.8%, because this is a zero-sum indicator. All of the scenarios 1 to 4 are based on real situations in different parts of the world. So which KPI should I use instead of % system input volume? Leakage KPIs are used for several purposes: setting targets and tracking changes in performance for an individual system, or technical performance comparisons between different systems, or drawing general conclusions from single or multiple systems, together with pressure and other context factors. This table, which summarises conclusions from a 2015 European Commission report with 16 case studies, shows which KPIs are fit for which purposes and which are not. The footnote recognises that at around 20 connections per kilometre, the leakage components on mains and on services are about equal in well-managed systems. At lower connection densities than 20 per kilometre, most leakage is likely to be on the mains. At higher connection densities than 20 per kilometre, the majority of systems, most leakage is likely to be on service connections. For more information on the most appropriate water loss KPIs to use, please visit the Leak Suite Library website at the link shown. Why not join over 140 professionals from 27 countries and sign up for the Professionals Abandon Percentages initiative also on the Leak Suite Library website. You can also access the recent presentation on UARL, ILI and system correction factors by Alan Lambert and Kate Stanton-Davis at the IWA Performance Indicators Conference in Amsterdam during November 2023 by following the link here.